Good day, viewers. Welcome to this class. And today we'll be looking at physics JAMB past questions. And these past questions are collated from different years. So the year is in front of each question. Moving on to the first question. It says, under which condition is work done? So they're asking you simply, what is the definition of work as per physics? So option A says, a man supports a heavy load on his head with hands. Option B says, a woman holds a pot of water. Option C says, a boy climbs onto a table. Option D says, a man pushes against a stationary petrol tanker. Now, for work to be done, the object on which a force is applied must move a particular distance. So in all of these, the man that supports a heavy load, he has not done any work because the load did not move a particular distance. The woman that holds a pot of water has not done any work. A man that pushes against a stationary petrol tanker has also not done any work because the petrol tanker did not move. So the only person who has done work here is a boy that has climbed onto a table. So he has moved a particular distance and he applied force in climbing. So the correct answer to this question is option C. So that takes us to question number 2, which is, in order to remove the error of parallax when taking measurement with a meter rule, the eye should be focused dash. So where are you going to focus your eye in order to avoid error due to parallax? Now remember when we talked about error, we said that what error due to parallax is a type of error that is caused by the observer. So the inability of the observer to note the exact position of measurement is what we call error due to parallax. So when you're observing your meter rule, you have to what? Be looking straight at the meter rule downward, vertically downward. So as you're looking straight at the meter rule, you'll be able to what? Read the exact position of your measurement. So let's look at our options. Option A says you have to what? Be focused slantly towards the right on the markings. Option B says slantily towards the left on the markings. Option C says vertically downward on the markings. Option D says vertically upward on the marking. So the correct answer to this question is vertically downward on the marking, which is option C. That takes us to the next question, and this question is gotten from 2003. It says, a load is pulled at a uniform speed along a horizontal floor by a rope of 45 degrees, at 45 degrees to the floor. So here I'm having, let's say I have a block and it is pulled, so by a force. So the force here is going to be tension. Why? Because I'm having what? A rope. So, and then they said the angle at which this load is pulled to the floor here is 45 degrees. And then in the question it said, if the force in the rope is 1,500 Newton, so here my tension is 1,500 Newton. What is the frictional force? The frictional force is the force that is opposing this motion. So this is the frictional force moving in opposite direction. So, and we know that our frictional force is equals to F cos theta. So this is the same thing as saying that I have tension cos theta because the force here is the tension. So this will give me 1,500 times cos 45. So that will give me 1060 Newton. So the frictional force here is 1060.6. Okay, there's a 0.6. So this is approximately 1061 Newton. So the correct answer to this question is option D, 1061 Newton. Moving on to question number next, it says, this question is what? 2008 question. It says, if a wheel 1.2 meters in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. So we are given the diameter of the wheel to be 1.2 meters, and then we are told that it rotates at a revolution. So I have the revolution here as 1 rev per second. Then say calculate the velocity of the wheel. Now we know that the velocity of the wheel here, velocity is supposed to be the distance moved divided by distance over the time. Now, but this wheel is what? Circular, and because it is circular, it's going to be having the circumference. So instead of us to be talking about the distance moved by the wheel, we're talking about what? The distance moved around the what? Circular wheel, which is what? The circumference of the wheel. And the formula for calculating the circumference of the wheel is going to be what? 2 pi r. And since here we're not given the radius, we know that our diameter is the same as what? 2 radii, which means that my 2 pi r here will become pi d. So this is the same thing as saying that if I want to do this, now in this question we're also not given the time, but we're given what? Revolution. And we know that if you look at this, they said what? Revolution is what? 1 revolution per second. This is the same thing as saying that what? Revolution here is talking about rotation over time. So which automatically changes our formula here to become the velocity to be equals to pi d times revolution. So this is the same thing as saying that I have pi times 1.2 times 1, because my revolution here is what? 1. So this is the same thing as saying I have so this will give me 3.77, which is approximately 3.8. So I have 3.77 meter per second or 3.8 meter per second. So looking at our option here, you see that what? The correct answer is option B, which is 3.77 meter per second. Moving on to the next question. It says, this question is gotten from 2014. It says, a quantity which requires magnitude and direction to be specified is dash. Now, we talked about this in a previous video where we did a topic on, and we talked about vectors and scalars. Now, a quantity that requires both magnitude and direction to be specified is called a vector quantity. And if you look at all our quantities here, which one of them is a vector? Temperature is a scalar quantity, distance is a scalar quantity, mass, because it is a fundamental quantity, is also a scalar quantity. So the correct answer to this question is displacement, which is what? A vector quantity, which is option C. Moving on to the next question. This question was gotten from 2022. It says, a bar magnet is placed near and lying along the axis of a solenoid connected to a galvanometer. The point of the galvanometer shows no deflection when dashed. So they are telling you that this magnet was placed in a solenoid, and when does this magnet not cause a deviation in the galvanometer? When does it not cause a reading on the galvanometer? So let's look at our option. Option A says the magnet is moved towards the stationary solenoid. Option B says there is no relative motion. Option C says the magnet is moved away from the stationary solenoid. Option D says the solenoid is moved away from the stationary magnet. Now, the only point where there is no deflection. So if you move the magnet towards the solenoid, there will be a deflection. If you move the magnet away from the solenoid, there will be a deflection. If you move the solenoid away from the magnet, there will also be a deflection. So the only time when there is no deflection is when there is no relative motion, when there is no comparison between the motion of the solenoid and the magnet. So the correct answer to this question is option B, which says there is no relative motion. So let's move to the next question, which says, this question was gotten from 2016, and it says, a charged particle is moving in a uniform magnetic field. If the direction of motion of the charged particle is parallel to the magnetic field, the path of the charge will dash. So they're asking us, what will be the path of the charge when the particle is moving in parallel direction to that of the magnetic field. So if the particle is moving in parallel direction to that of the magnetic field, the path will be a straight line. So they will both be moving in the same direction. So they might not be moving in the same direction, but they are both side by side. So it is is a straight line. So because they are parallel. So the correct answer to this question is it will be a straight line. So let's move to the next question. This question was gotten from 2016. It says, the resultant of two forces is 50 Newton. So this is a calculation question. The resultant of two forces is 50 Newton. So I have my resultant here as 50 Newton. If the forces are perpendicular to each other, so this means that here, look at this. I'm having these forces. This is their resultant. So they are perpendicular to each other, which means that the angle between them is what? 90 degrees. Then said, one of them makes an angle of 30 with the resultant. So let's say this is force F1 and this is force F2. And they're saying that one of them makes an angle of 30 degrees. So this makes an angle of 30 degrees, for example. Then they're asking us, with the resultant, find its magnitude. So we're trying to find what? The magnitude of the force that makes an angle of 30 degrees with the resultant. And how do we do that? So looking at this triangle, you know that this is what? A right angle triangle. And in the principle of right angle triangle, whenever there is an angle given in the right angle triangle, you can employ the principle of trigonometrical ratios, which we simply call SOHCAHTOA. So looking at this, if we're looking for this side, and I have an angle here, this part here will become opposite. This part here will become the hypotenuse, and this part here will become adjacent. So looking at this, it means I have what? Adjacent, because I'm looking for F1, and then I have what? My resultant, which is what? The hypotenuse. So when I have what? Adjacent and hypotenuse, it means I'm looking at what? Cosine of angles. So which means that what I have here will become cos theta is equal to adjacent over hypotenuse. So if I apply this principle here, this means that I have cos 30 will become adjacent is F1 over my hypotenuse there is 50 Newton. This means that my F1 is equal to 50 cos 30. So if I multiply that, that will give me 43.3 Newton. So the correct answer to this question is 43.3 Newton, which is option C. Let's move to the next question. This question was gotten from 2010. It says, a stone and a feather are dropped from the same height above the Earth's surface, ignoring air resistance. Which of the following is correct? So this was stated by Sir Galileo Galilei when he said that whenever the influence of force and other particles are not what? Directly affecting object, irrespective of their mass, when dropped at the same time, they will get to the ground at the same time, irrespective of their mass, because there is no gravitational pull and there are no other forces acting on it. So because of that, we are going to explore this question. And since this feather and the stone were dropped together, the stone is heavier than the feather, but because they are what? They are ignoring air resistance, which means that we are what? Assuming that this was done in a vacuum where there is no gravity and there is no the influence of other forces acting on it. So option A says the feather will be blown away by the wind while the stone will drop steadily. Option B says the stone and the feather will both reach the ground at the same time. Option C says the feather will reach the ground first. Option D says the stone will reach the ground first. So the correct answer is the stone and the feather will reach the ground at the same time. Why? There is no air resistance. So the correct answer is option B. So let's move to the next question. This one got it from 2015. It says, what is the inductance of an inductor whose reactance is 1 ohms at 50 over pi hertz? So this question is based on AC circuit, where we talked about the inductance, the capacitor, and the resistor. So in this case, we're only talking about what? The inductor. So an inductor, we have inductance. So in this question, we're told that the inductive reactance XL was given as 1 ohm. And then we're given the frequency as 50 over pi hertz. and we are asked to find the inductance, which we do not know. So, and we know that our inductive reactance XL is equals to 2 pi FL. So, if we apply this principle and these formulas here, this means that if I make L so the formula here, it means that my L is equals to XL over 2 pi F. So, this is the same as saying that my L is equals to 1 divided by 2 times pi times my frequency here is 50 over pi. So pi will cancel out pi. That will give me 1 over 100, which will give me 0.01. So this will give me 0.01 Henry. So the correct answer to this question is 0.01 Henry, which is what option B. Okay, moving on to the next question. This was adapted from 2019. It says a mass of 0.5 kg. So we have our mass as 0.5 kilogram. Is whirled in a vertical circle of radius 2 meters at a steady rate of 2 rev per second. So we are given frequency as 2 rev per second. Calculate the centripetal force. So we have to find the word centripetal force. We do not know. And we know that centripetal force is equals to m omega square r. So in order for us to find omega, we know that omega is equals to 2 pi f. So this is the same as saying that my omega, if I impute my centripetal force into that, so this means that my centripetal force here will become m 2 pi f squared r. So if I impute my values, this will give me 0.5 times 2 times pi times my frequency was 2 squared times 2. So this will give me 0.5 times, so I have 4 pi so that will give me 4 pi. Let's just leave it at pi until after we squared. This is times 2. So if I multiply 2 times 0.5 here will give me 1 times. So I have, that will give me 16 pi square. So that's 157.91. That's approximately 157.9 Newton. So the centripetal force is 157.9, or if you round it up to whole numbers, you're going to have 158 Newton. So the correct answer to this question is option C. Moving on to the next question. This was gotten from 2010. It says a certain far-sighted person cannot see objects that are closer to the eye than 50 centimeters clearly. So we have the V to be 50 centimeters, which is the same as saying I have 0.5 meters. So determine the power of the converging lens. So we're looking for the power of the converging lens, we do not know, which will enable him to see at 25 centimeters. So it means that my object distance is 25 centimeters, which is equivalent to say 0.25 meters. So we know that our mirror formula or lens formula says that 1 over focal length is equals to 1 over image distance plus 1 over object distance. And here, because we are using a converging lens, it means that my image distance is going to be what? Negative, because the image is supposed to be what? Virtual. So this means that I'll be having minus 0.5 meters. So with this means that this formula will become 1 over f is equals to 1 over u minus 1 over v. So with this, it means that 1 over f is equals to 1 over 0.25 minus 1 over 50 over 0.5. So this will give me, my SCM here will give me 0.5. This 1 over f is equal to, so if I divide by 0.25. That will give me 2 times this. I'll get what? 2 minus 1. So at the end of the day, I'll have 1 over f to be equals to 1 over 0.5, which is same as saying that 1 over f is equals to 2. So with this, now I know that the power in the converging lens is equals to 1 over f. So this is the same as saying that the power in this particular converging lens is equal to 2D or 2 dioptry. So this particular question has no option in the answers here. So looking at our options here, we have 0.06, we have 0.02, we have 0.03, 0.04. So the correct answer to this question is no option is correct, which is option E. Moving on to the next question, it says, this question was gotten from 2016. It says, if the magnification of a virtual image formed by an object, so in this question, they are talking about magnification and they're talking about a virtual image. So here, they're saying if the magnification of a virtual image formed by an object 10 centimeters, so the object distance here is 10 centimeters from a convex lens is 2. So the magnification was given as 3. Convex lens, not less, is 3. Then the focal length of the lens is dash. So the focal length is unknown. Now, for us to solve the question, we have to first of all find the image distance, which is V, we do not also know. So we know that our magnification is equals to V over U, which is image distance over object distance. This means that I have 3 is equals to V over 10, which means that my V is equals to 30 centimeters. Now, because this question here is talking about a virtual image, because it's talking about a virtual image, it means what I'll be having is negative here. So because this is negative, it means I remember that my lens formula says 1 over f is equals to 1 over v plus 1 over u. So this is the same as saying 1 over f is equals to 1 over u minus 1 over v. So this will mean that my 1 over f is equals to 1 over 10 here minus 1 over minus 30. Okay, 30, because I already put the minus here. So this is 1 over f is equals to, my SCM here is 30. 30 divided by this, I'll get 3 times this, I'll get 3 minus, divided by this, I'll get 1, so I have 1. So this means that my 1 over focal length is equals to 2 over 30, which is the same as saying that 2 focal length is equals to 30, which means that my focal length is equals to 30 over 2, which means that my focal length is equals to 15 centimeters. So the correct answer to this question is 15 centimeters, which is option D. If at this point you have not subscribed and you have been enjoying this video, please subscribe and go to the channel for more videos that we have done. So let's move to the next question. Question number 20. It says, this question was gotten from 2020, sorry, and it says a machine gun with a mass of 5 kg. So we're talking about a machine gun here. So a machine gun with a mass of 5 kg. So we have a machine gun with a mass. So the mass of the gun is 5 kg. Fires a 50-gram bullet. So the mass of the bullet is 50 grams at a speed of 100 meters per second. So the velocity of the bullet is 100 meters per second. The recoil speed of the gun. So the velocity of the gun is unknown. Now, when you fire bullet from a gun, then you call the recoil of the gun. The gun bounces back at a particular speed. So if you are not holding the gun rightly, you most likely be the first person to fall down even before the person you are trying to shoot or the thing you are trying to shoot at gets the bullet. So Why? Because there's what a recoil gotten from what Newton's third law of motion that says that what to every action there's an equal and opposite reaction. So as you are shooting the gun, that's what an action. There's a reaction from the gun, which is the recoil of the gun. And according to Newton's law, if you follow this principle, it says that the magnitude or the momentum before collision must be equal to the momentum after collision, which means that the recoil of the gun, so this is bullet, mass of the bullet, velocity of the bullet must be equal to mass of the gun, velocity of the gun. So the momentum of the bullet must be equal to the momentum of the gun. So looking at this, our mass here is in grams, so we'll convert this. So this is 50 divided by 1000, and that will give me 0.05 kg. So if you impute that, it means I have 0.05 times 100 is equals to 5 times velocity of the gun. So divide both sides by 5 divided by 5. So this will mean that I have 0.05 times 20. This means that the velocity of the gun is equals to 1 meter per second. So the correct answer to this question is 1 meter per second, which is option C. Moving on to the next question. This was adapted from 2014. It says a wheel and an axle. So here we're talking about wheel and axle, and that is on what? Machines. So it says a wheel and an axle is used to raise a load whose weight is, so the load is 800 Newton. When an effort, so the effort here is 250 Newton. When an effort of 250 Newton is applied, if the radii of the wheel, so we have the radii, so we have the radii of the wheel and the axle, so the radius of the wheel is 800 millimeters, and the radius of the axle is 200 millimeters, respectively. The efficiency of the machine is, now remember that we have done a full video of machines earlier. Don't forget to go to our channel and check it out. So moving on to the question, so let's solve this. Now for us to solve this question, we know that the efficiency of the machine is equal to mechanical accuracy over velocity ratio times 100 over 1. So for us to solve this question, we have to find out what the velocity ratio is. We have to find out what our mechanical accuracy is. But our mechanical accuracy, MA, is simply load over effort. So that can easily be sorted out. But our velocity ratio for wheel and axle is the radius of the wheel over the radius of the axle. So if you impute this into our new formula, it means that our efficiency is going to be load over effort divided by radius of the wheel over radius of the axle times 100 over 1. So if we apply this, in order to simplify our work, if we apply this in our calculations, it means what I'll be having is efficiency will be equal to 800 over 250 divided by 800 over 200 times 100 over 1. Now somebody might be wondering, why is it that I did not convert my millimeters to meters here? So the reason is very simple. Because I'm having velocity ratio, and velocity ratio does not have any unit, and I'm having the radius over the radius, so they will cancel out themselves. So automatically it means no unit to be left. So there is no need for any conversion. If you convert, you're going to arrive at the exact same answer. So this is the same thing as saying that I have, this will cancel out this. I have 80 over 25 divided by, so divided by 4 times 100 over 1. So this will give me 80 over 25 times 1 over 4. 4 here 1, 4 here 20. This is times 100 over 1. So I have 20 over 25 times 100 over 1. 25 here 1, 25 here 4. So that will give me 20 times 4, which will give me 80%. So it means that the correct answer to this question, or the efficiency of this machine, is simply 80%, which is option B. It says a bar magnet is divided into two pieces. Which of the following statement is correct? Option A says two new magnets are created. Option B says the magnetic field of each separate piece becomes stronger. Option C says the electric field is created. Option D says the bar magnet is demagnetized. Now, when a bar magnet is a magnet that has its pole clearly written. Now, when a bar magnet is divided into two, so if you divide the bar magnet into two, automatically you are going to form what? Two magnets that has both north and south pole. So when you divide it into two, you'll be having what? Two magnets that will be what created, and they will both be having the north and the south pole. So the correct answer to this question is option A. Two new magnets are created. So we've come to the end of this class. Don't forget to go to the channel for more videos just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao,